Hello friends, I am Mrs.S.M.Shaikh, Assistant Professor from Electrical Engineering Department, and today in today's lecture we shall see the different busbar arrangements. So this is the YouTube channel, YouTube link. You can go on this link and see the different videos that are available for the busbar arrangement. So the first busbar arrangement that we'll see today is the single busbar. So as the name suggests, there is only one single bus bar in this arrangement. It consists of all circuits connected to a main bus. A fault on the bus or between the bus and the circuit breaker will result in an outage of the entire bus or substation. Failure of a single circuit breaker will also result in an outage of the entire bus. So the advantages of the single bus bar arrangement is that it is the simplest and least expensive of all the configuration. This configuration requires less installation area and it can be easily expanded. Disadvantages: it is not at all reliable. The same single bus bar configuration we can see in the actual diagram how these are connected. So you can see there is an incoming line over here which is connected to this 11 kV bus bar, right? So this is an 11 kV incoming line through the circuit breaker, through the isolator. It goes through the circuit breaker, again an isolate, and connected to the bus bar, the 11 kV bus bar. From the same bus bar there is an outgoing line connected through the transformer, 11 kV to 400 volt transformer. There's a lightning arrestor also on this bus bar. So basically all the equipments, whether it is an incoming line or the outgoing line, are all connected on the single bus bar. So any fault in this one single bus bar will result in a complete outage of all the loads that are connected to this. So that is the main disadvantage of single bus bar. The second one is single bus bar arrangement with bus sectionalization. In this arrangement, here again there is a single bus bar, okay, but now this bus is divided into two parts or two sections. That is why the name with bus sectionalization. So there is a circuit breaker which is connected between the two parts of the single bus, and therefore there is this isolates. So if you want to work on the right hand side, then I just have to open the isolator and the circuit breaker of this side, and this entire thing is de-energized. The right hand side is de-energized for me. My loads on the left hand side can still be operating in that case. So if you see this diagram also, there's an incoming line and an outgoing line connected through a bus coupler, that is a isolator, a bus coupler, a circuit breaker and an isolator, which connects to the section 2, bus section 2, where again there is an incoming line and an outgoing line. So in this, the advantage is that you get partial reliability. At least if there's fault in one of the sections, either on bus section 1 or bus section 2, then the other section is operational and is not disturbed. Whereas in the single bus bar, if any fault is there on any part then of the bus, then the entire loads are affected. So here at least the half of the load can be carried out if there is fault in any one section. So that is the main advantage of single bus bar arrangement. So again, this is also a connection diagram for single bus bar arrangement with bus sectionalization. Here the bus has been divided in two sections. There are two 33 kV incoming lines connected to section 1 and section 2 as shown in the figure. Each 11 kV outgoing line is connected to one section to the transformer, right? This is the transformer here, and here 33 kV by 11 kV and a circuit breaker. You can see this 33 kV oil circuit breakers are there. It is easy to see that each bus section behaves as a separate bus bar. The third type is the main bus and the transfer bus, or it is also called as the duplicate bus bar system. In this arrangement, one or more bus is added to the single bus substation scheme. One or more circuit breakers may be used in this arrangement to make connections between the main bus and the transfer bus. So basically there are two buses over here. This is called as the main bus and this is called as the transfer bus. So both these buses are tied together through a circuit breaker and an isolator connection. So basically all the loads from the main bus can be transferred smoothly to the transfer bus. So that is why it is also called a duplicate bus bar. So this system consists of main bus and the spare bus. So if you can see in this, the detailed diagram is given over here. This is bus 1, it is a 66 kV bus, and here is the bus 2. It is also called as spare bus or transfer bus. And these two buses are connected to a bus coupler arrangement, which is through isolator, circuit breaker, and again isolator. So now if you see the load, that is the incoming lines are connected between these two isolators. So the moment I close all the upper isolators, that means the main bus is functional and the load is being supplied through the main bus. But if there is any problem on the main bus, then I can easily transfer all the load through the bus coupler to that spare bus or the transfer bus, and I can still continue without any disturbance to my load. That is why it is called the duplicate bus bar scheme. The incoming and outgoing lines remain connected to the main bus bar. However, in case of repair of main bus bar or fault occurring on it, the continuity of the supply or to the circuit can be maintained by transferring it to the spare bus bar. For voltages exceeding 33 kV, duplicate bus bar system is mostly used. So, while transferring the load to the reserve bus, the following steps may be taken. Close the bus coupler, that is circuit breaker, so as to make the two buses at the same potential. Close isolators on the reserve bus. So, this is your reserve bus or transfer bus or spare bus. Open isolators on the main bus. The load is now transferred to the reserve auxiliary bus and the main bus is disconnected. The advantages: it ensures a continuity of supply in case of the bus fault. In the event of occurrence of fault on one of the bus, the entire load can be transferred to the other bus. Repair and maintenance can be carried out on the main bus without interrupting the supply, as the entire load can be transferred to the auxiliary bus. Each load can be supplied from either bus. The in-feed and load circuit may be divided in two separate groups if required from operational consideration. The testing and maintenance of feeder circuit breakers can be done by putting them on spare bus, thus keeping the main bus undisturbed. The maintenance cost of substation is lowered. Thus, the bus potential can be used for relays. The disadvantages, the very first and the main is the cost. So it is very expensive, and the bus is maintained or expanded by transferring all of the circuits to the auxiliary bus, depending upon the remote backup relays and breaker for removing faults of the circuit. During this condition, a line fault on any of the circuits of the bus would shut down the entire station. So that is the main disadvantage. That's all in this video. For more on bus arrangement, see my other video. Thank you.